Alright, so the next ones that we needed to do said to perform the indicated operations, assume all variables represent positive real numbers. So 78, we have 4 times the square root of 18k minus the square root of 72k plus the square root of 50k. So as this sits, does it look like we can add those / subtract them?
You can add the last two, right?
Are they the same?
Oh, no.
No. So we need to see if we can take anything out and then go from there. So, looking at the numbers, they all have a k in them, so, and there's only one of them, so I know I can't take any k's out. So I'm just looking at the numbers that are inside. So 18 breaks down to 6 and 3. 6 is 2 and 3. So I can take out a 3, and then I'll be left with 2k inside. So that'll be 4 times the square root of, 4 times 3 times the square root of 2k. I'm going to go ahead and put this minus sign here so I don't forget it. So I'm going to break down 72. 8 and 9. 8 is 2 and 4. 4 is 2 and 2. 9 is 3 and 3. So I can take out a group of the 3's and a group of 2's, and I'll have 1, 2 left inside. So on the outside, I have 2 times 3, and then the square root of 2k. And then I'm going to go ahead and put the plus. I'm going to try to break down 50. 25 and 2. 25 is 5 and 5. So I can take out a set of 5's. I'm left with a 2k inside. So now all my radicals are the same. Okay, so I can combine them. So I've got 12 square root of 2k minus 6 square root of 2k plus 5 square root of 2k. And then the radicals are kind of like what make it a like term. So I basically am just combining them into one. So 12 minus 6 is 6 plus 5 is 11. So this will be 11 square root of 2k for my final answer. Any questions on that? I know it's kind of a lot for something that should be relatively simple. Just adding and subtracting. Um, 86. Square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2. Does this look like anything that we might know?
Would that just be square root of 7 times square root of 3?
So those radicals are not the same, so we can't combine them. If it was like the square root of 5 plus the square root of 5, it would be 2 square root of 5. Foil? Is this a special type, though? Other one. Difference of squares. But yes, if you didn't recognize it was a difference of squares, you could just FOIL it. Same thing's going to happen either way. So, Square root of 5 times square root of 5 is 5. And then if we do, it'll be minus the square root of 2 times the square root of 5, and then plus the square root of 2 times square root of 5. So that's us canceling, which is what makes it a difference of squares. So then it'll be minus square root of 2 times square root of 2 is
2.
well, yeah. So minus 2. So then that's 3. That one's a little nicer than the previous one. Um, 92. 4 square root of 5 plus the square root of 2 times 3 square root of 2 minus the square root of 5. So when we multiply radicals, we can multiply what's inside of them. But when we're adding and subtracting, it's just they have to be the same to add them. So on this one, we're going to start with foiling. This one isn't a special type. So this is going to be 12 square root of 10. So we multiply what's outside, multiply what's inside, and keep it in the radical. Then that one is going to be 4 square root of 5 times negative 5 is going to be, well, square root of 5 times square root of 5 is 5, times 4 is 20, and it's a minus, so minus 20. I'll just write for reference here. This is 4 times 5. Negative, I guess. And then square root of 2 times 3 square root of 2 is going to be 6. So this is 3 times 2. And then the last one, square root of 2 times negative square root of 5 is going to be negative square root of 10. We following so far? Good. And then I just want to combine like terms, so I can combine the stuff that has the square root of 10, and then I can combine those two things right there. So I end up with 11 square root of 10 minus 14. Any questions about that? They can get as crazy as this, but we're not going to actually do this one, but I'm just going to show you. You don't need to. I'm not actually going to solve it. I'm just showing you how crazy it can get. So 8m squared n cubed times cube root of 2m squared all over the cube root of 32 m to the 4th n cubed. So
I would just skip that one.
it's fair. Just so that you've seen it, all that you would need to do is basically in each radical break down and take out anything in groups of 3 since they're all cube roots, and take them out, and then you can multiply what's inside. Because these have on top, they have the same root, you can multiply what's inside of them and like put it all under 1, and then break it down. Sometimes it's easier to break it down first, but once you multiply it, it might allow it to break down more. And then we would break down the bottom and then just start canceling stuff from there. So I just wanted you to see it, that it can get that crazy, but we are not going to get that crazy. Any questions about any of that? We're good. Then for practice on this stuff that's new, 77, 85, and 91. So not that much more, just a little bit.